Introduction to Kafka. Preface. Content of this lecture: we will define what is a Kafka, we will see the use case of Kafka and Kafka as a data model, Kafka as a architecture, types of messaging system, importance of Kafka as the broker. So, before we go ahead, let us see what is the use of Kafka in big data. So, the Kafka is used for the data ingestion of big data computing. So, in this particular discussion, we will see the details of the Kafka and how the Kafka can be used for data ingestion. Before we go in more detail, let us understand two important things using this particular picture. One is the batch. Batch jobs means the stored. This is the stored water. This is, if it is consumed, then it is called a batch processing. Whereas the water which is in the form of a stream, if we are consuming, then it is called a stream. So, it is the data, if we are consuming in our scenario, it is called a batch data. If we are using the stored data for its consumption, that is through the databases, data warehouses, and so on. And this is the streaming data. If we are consuming the data for any application, such as the Twitter stream data or the socket API socket connection, which brings into the network data and so on. So, those data is called the streaming data. So, as the data is flowing, we have to compute this particular data, then it is called the streaming data processing. So, this kind of data, here we have the big volume of data which is we have to store, that is the volume we have to deal in the big data. Similarly, the streaming data, that means data is moving very fast and we have to compute this processing, which cannot be done by a single computer system. So, that means how we have to compute in the real time this fast data. So, we will see here what do you mean by the how batch data and what is the streaming data and how we are going to handle these cases in the data ingestion system. So, what is the technology? So, we will be discussing the Kafka as the technology which deals with the both type of input sources of the data, that is the batch data as the input source and the streaming data as the input source. So, before we go ahead, let us see the Apache Kafka as the streaming data platform having the Unix pipeline analogy. So, just if you have familiar with the Unix pipeline analogy, now we will understand using that analogy about the Kafka, Apache Kafka. So, here in the Unix domain, you might have noticed that there are certain Unix commands, and we can now form a pipeline of these set of Unix command together, and this is called the Unix pipeline. So, similar to this analogy of Unix, we will see different components of Kafka. So, there is a Kafka core, which is like Unix pipes. This is called Kafka core. So, Kafka core is a distributed durable equivalent of Unix pipes. So, it used to connect and compose your large scale data application. The second aspect here is called Kafka streams, which is having the similar analogy as the commands you use in the Unix pipelines. So, these particular commands are used to transform the data which is stored in the Kafka. Third component is called Kafka Connect. So, Kafka Connect is an I/O redirection, just like here. And this indicates Kafka Connect. So, Kafka Connect is the I/O, it is having analogy with the I/O redirection in the Unix pipelines. So, it is used to get your data into and out of the Kafka system. So, if we draw a diagram of a Kafka system, we will have, this is called Kafka Connect. The next thing is about the Kafka streams. Kafka core, and then we have the Kafka streams. So, this is the complete picture, and here there will be the input sources. Input sources may be generating the batch data, streaming data, and this is called the input sources. And now here there will be an output or a consumers or output sources. This is called the Kafka cluster. Now, let us go and understand the design of each and every component of these Kafka, that is, what do you mean by the Kafka Connect and Kafka stream and Kafka core, and how together all of these components can be used to build the data ingestion and data computation pipeline in a big data scenario. So, Kafka is the high performance real time messaging system, and it is an open source tool and is the part of Apache project. So, the characteristics of Kafka are, it is the distributed and partitioned messaging system. It is highly fault tolerant, it is highly scalable, it can process and send millions of messages per second to the several receivers. So, the history of Apache Kafka was originally developed by LinkedIn and later on handed over to the open source community in the 2011. It became a main Apache project in October 2012. A stable Apache Kafka version 0.8.2.0 was released in February 2015. A stable Kafka version 8.2.1 was released in May 2015, which is the latest version. So, let us see some of the use cases of Kafka. So, Kafka can be used for various purposes for in the industries, such as Kafka can be used as a messaging service. That is, millions of messages can be sent and received in the real time using Kafka. So, real time stream processing, that means Kafka can be used to process a continuous stream of information in real time and pass it to the stream processing system such as Storm. So, log aggregation, that is Kafka can be used to collect the physical log files from multiple systems and store them in the central location such as SDFS. Commit log service, Kafka can be used as an external commit log for distributed systems. Event sourcing, a time ordered sequence of events can be maintained through the Kafka. So, these are some of the important use cases of Kafka which is used in different organizations and is used in applications. So, let us summarize it that Kafka can be used as a messaging servers for handling with the multiple number of messages and in the real time its computations. Real time stream processing, Kafka can be used to process continuous stream of information, and the log aggregation, that is Kafka can be used to collect the physical log files from multiple systems and store them to the central agencies. So, commit log service, Kafka can be used as an external commit log for distributed systems. Event sourcing, that is a time ordered sequence of events can be maintained through the Kafka. Apache Kafka, a streaming data platform. So, most of what a business does can be thought of as an event streams. So, they are used in the retail system in the form of orders, shipments and returns, in the financial system such as stock ticks, orders, etc. The website such as the page views, clicks, searches, and IoT, that means sensor readings and so on. So, all these are the data which is called the streaming data, which is required to be input into the systems, which is shown here in this particular diagram, that the input streams or stream data, which basically is in the form of the sales, and the shipment details also is a streaming form of data, then various price adjustments, reordering and inventory adjustments. So, all these are some of the data system which is out of the retail system. Similarly, in the financial systems, the stock ticks, different stock orders, that will be the stream data. Which is required to be computed as an event for the different business applications. Similarly, as far as the website is concerned, page views, page clicks, searches on the website also will generate the stream of the data as an event. IoT devices, wherein the sensors are reading, taking the readings and now generating the events streams out of this IoT sensor data, is also one of the streaming data platform and is supported in the Kafka. So, the Kafka we see here more than 1000 different companies worldwide uses Kafka in some form or the others, such as Netflix, eBay, Adobe, Cisco, and so on. All these big data companies they uses the Kafka in some form of analysis and computations. So, let us see some more Kafka example. So, aggregating users activity using the Kafka as an example. So, Kafka can be used to aggregate the user activity data such as clicks, navigation, searches from different websites of an organization. Such user activities can be sent to a real time monitoring system and Hadoop for. So, we can see here as an example of user activities, aggregating user activities, that means different users who are accessing through different portals will generate the stream of data, and that will enter into the Kafka cluster, and Kafka will, after computation, now it will give it to the consumers either for the real time monitoring, or it will store in the Hadoop offline file processing. So, Kafka data model consists of the messages and the topics. So, messages represent the information such as lines in a log file, rows of a stock market data, or an error message from a system. They are called messages. So, messages are sometimes grouped together into the topics. So, for example, log message or a stock message together are grouped together and called as the topics. So, the processes that publish messages into the topic in Kafka is known as the producers, and the processes that receive the message from the topic in the Kafka is known as the consumer. The processes or the servers within the Kafka that processes the messages are known as the Kafka brokers, and the Kafka cluster consists of set of brokers that processes the messages. Let us understand all these different components of Kafka through this particular picture. So, the group of messages is called a topic, and so here in this particular example we have shown two different groups of messages, that is topic 1 and topic 2. These topics are, or these messages are generated and those by the processes which we call it as producers. So, these particular topics are now processed using things which is called the brokers. So, brokers process them, and again these particular topics after the transformation will be passed on to the consumers. So, again let us understand that the data model in Kafka is the messages and the collection or the group of messages which is called the topics. So, data model in Kafka comprises of messages and topics. Now, these messages represents the information such as lines in a log file, row of a stock market data, or error messages. So, these are called messages. These messages are grouped together and into the different categories and called the topics. So, related messages are grouped together and they called as topics. Furthermore, the processes that publishes the messages into a topic in the Kafka is known as the producers. So, producers publishes the messages into the topic. So, the processes that receive the messages from the topics in the Kafka is known as the consumers. Now, the processes and the servers within the Kafka that processes the messages are known as the brokers. So, a Kafka cluster consists of set of brokers that processes the messages. So, let us see what we mean by the topic, which is nothing but the data model. In Kafka. So, the topic is the category of the messages in Kafka. So, the producers publish the messages into the topics and consumers read the messages from the topics. So, the topic is divided into one or more partitions, and partition is also known as the commit log. So, each partition contains an ordered set of messages. So, each message is identified by its offset in the partition, and the messages are added at one end of the partition and consumed at the other end of the partition. Let us understand the concept of topics and partition by this particular simple example. So, here the topics are nothing but the publishers publishes the messages into the topics, and once they do this, then they have to write down. So, the publishers, they will do the write operations on the topic, and the consumers will read the messages out of from the topic. So these operations, write is related to the publisher, read operation is related to the consumer, and the topic is divided into one or more partition. For example, this is the topic, simple, it is divided into two partitions, partition 1 and partition 2. So each partition is known as the commit log. So partition is nothing but a commit log. So each partition contains an ordered set of messages that we see the order in which the messages are received. So each message is identified by its offset into each message is identified by its offset in the partition. Message is nothing but an offset into the partition. So messages are added at one end of the partition, like here it will be added, and consumed at the other end of the partition, that is added with the help of using the write command and consumed with the help of read command. Having understood the topics, the partition, the offset, the write and read, the publisher and consumer, let us understand the partition in more details. So topics are divided into the partitions, which are the unit of parallelism in Kafka. So partitions allow the messages in a topic to be distributed, to multiple servers. So a topic can have any number of partitions, and each partition should fit in a single Kafka cluster, and the number of partitions decide the parallelism of that particular topic. So partition distribution, partition can be distributed across Kafka cluster, and each Kafka server may handle one or more partition. And here in this example, which is shown that this server 1 will handle partition 0 and another server 2 will handle the partition 1, or both partition 0 and 1 can be handled by one server. So a partition can be replicated across several servers for fault tolerance. So one server is marked as the leader for the partition and others are marked as the followers. So leader controls the read and write operation for the partition, whereas the followers will replicate the data. Now if the leader fails, one of the followers automatically becomes the leader. Zookeeper is used to do the leader selection process here to maintain. So here, which is shown as the server, this is nothing but a leader, and the same partitions are replicated in the other servers also, and they are being replicated and called as the followers. Similarly, this particular server is nothing but the leader, and same partition is replicated on the other servers which are called followers. And this particular leader election across different followers is done by the zookeeper. This is called partition distribution. Now let us see the producers. So producer is the creator of message in Kafka. So the producer places the message into a particular topic. So producers also decide which partition to place the message into it, and the topic should already exist before a message is placed by the producer. Messages are added at one end of the topic, one end of the partition. So, this is the example which is shown here, that the producer is producing the messages, and different messages are now joining the different topics depending upon the topics which are to be partitioned. So, here the producer will add the messages to different topics, and consumer is the receiver of the message in the Kafka. So, each consumer belongs to a consumer group. A consumer group may have one or more consumers. So, consumers specify what topic they want to listen, and the message is sent to all the consumers in a particular consumer group. A consumer group are used to control the messaging system. Now, let us see all these components together and see the overall Kafka architecture. So, Kafka architecture comprises of the brokers that take the messages from the producer and add to the partition of a topic. Broker provide the messages to the consumer from the partition. So, a topic is divided into multiple partitions. So, the message is added to the partition at one end and consumed at the other end, that we have already seen, and that is being coordinated by, or that is handled by, the brokers. So, each partition will act as the message queue, and the consumers are divided into the consumer groups here in this scenario, which is shown over here. And all the brokers together are called the Kafka clusters, and the different server machines are used with the help of Zookeeper in this scenario, which is shown. Now, different type of messaging systems are available as on date. So, Kafka architecture supports publish, subscribe and queuing system. So, publish subscribe system on the left is shown that each message is received by all the subscribers, that is, or the consumers. So, each subscriber receives all the messages, and the messages are received in the same order that in the same order that they are being produced by in the publish subscribe system. Whereas in the queuing system, each message is consumed by only one consumer, and each message is consumed by any one of the available consumers, and messages are consumed in the order in which they are removed. So, here there is a difference between queuing and publish subscribe system. Both the models of messaging system is supported in the Kafka architecture. Now, let us see the queue system, which is supported by the Kafka. So, here the producer will produce the message, and this will be put into the partition, or it will be divided into the topic with the help of the broker, and a particular consumer will consume this particular message in this particular system. So, we have to see that each message has to be consumed by only one consumer, and each message is consumed by any one of the available consumers. So, and the messages are consumed in the same order that they are being received. So, here you can see that consumer number 1 is available, so it will consume message 1 and 4. Similarly, consumer number 2 is now, when it is available, it will consume 2 and 5, and when consumer 3 is available, it will consume 3 and 6. So, any of these consumers will consume, and every message is consumed by only one consumer. So, that is called the queuing system, and it is being supported over here. Whereas in publish subscribe system, every message is received by all these consumers. So, you see here in this publish subscribe system, so this message 1, 2, 3, 4, 5, 6 is being consumed in the same order by all the consumer groups. Now, as far as the brokers are concerned, brokers are the Kafka processes that process the messages in Kafka. Each message, each machine in the Kafka in the cluster can run one broker. So, they coordinate among each other using Zookeeper. One broker is act as the leader for the partition and handles the delivery and persistence, whereas others are act as the followers. So, Kafka guarantees the following. First is the messages sent by the producer to a particular topic and the partitions are appended in the same order. Second, guarantees is the consumer instance gets the message in the same order that they are being produced. Third, guarantees is that a topic with the replication factor n tolerates up to n-1 failures. Now, replication in Kafka. So, Kafka uses primary backup method for the replication, that is one machine which is one replica is called the leader and chosen as the primary, and the remaining machine are the replicas chosen as the followers and acts as the backup. So, the leader propagates the write to the followers and the leader waits until all the writes are completed on the replicas. If the replica is down, it is skipped for the write until it comes back. If the leader fails, one of the followers will be chosen as the new leader, and this mechanism can tolerate n-1 failures if the replication factor is n. Now, persistence in Kafka. So, Kafka uses a Linux file system for persistence of the messages. So, persistence ensure no messages are lost. Kafka relies on the file system page caching for fast reads and writes. All the messages immediately written to a file in the file system, and messages are grouped as the messages set for the most efficient writes. So, messages sets can be compressed to reduce the network bandwidth. The standard binary message format is used among the producers, brokers, consumers to minimize the data modification. So, again, in a nutshell, let us see how the streaming data platform is supported in Kafka. So, Apache Kafka is an open source streaming data platform, and it supports with the three major components. Kafka Core is a central hub to transport and store the event streams in a real time. Kafka Connect will now is the framework to import the event streams from other sources into the Kafka and export the event streams from Kafka to the destination data systems. Kafka Stream is a Java library to process event streams live as they occur, and for further reading this is given here the references for Kafka Streams code examples and Kafka Stream Java docs, and first book on Kafka Streams and Kafka Streams download is given at https kafka.apache.org downloads. Conclusion: Kafka is high performance real time messaging system. Kafka can be used as an external commit log for distributed system. Kafka data model consists of messages and topics. Kafka architecture consists of brokers that take messages from producers and to add to the partition of a topic. Kafka architecture supports two types of messaging system called publish, subscribe and queuing system, and brokers are the Kafka processes that process the messages in the Kafka. Thank you.